All right, continue the notes. So let's see. So class.
Yes.
All right. So for those people that are here participating, thank you very much. For those people that are going to walk in really, really late, then interrupt the conversation with some strange rambling, no thank you. All right. Okay, power rule function, find derivative. G is differential of function and is an integer. There we go. No. Okay, there we go. So, let's take a look here. So I could actually just U this instead, which would make just as more sense. Let's say, so U would be what? Very good. Du, so I'm starting to rewrite it as Leibniz. So du is going to be negative 3x squared, right? Good. Now, I'm going to rewrite it. So now it's going to be u to the negative 5. Okay. So again, like I said, I'm going to write it as Leibniz so you guys can see what's going to happen. Because we're going to start getting into implicit here soon. So take the derivative of this, because this says the function f taking the derivative of x, but there is no x because I substituted it, right? I substituted. So this is going to turn into negative 5u to the negative 6, and since it is, I'm taking the derivative of something that is not there. So I took a derivative of u, and u is not there, in that times du, or dy dx. And this is going to come into play into my integration also. So that's a derivative of u. You want the full thing right there? I'll write it out. So, sub back. So it's going to be f prime of x is negative 5 times my u, which is the quantity of 3 minus x cubed, close, raised to the negative 6 times my du, my derivative of u, which is going to be negative 3x squared. So can I kind of put that together? Yeah. Okay, I can't put it inside the quantity right here, but I can put it out front. So negative negative is going to make that a positive. 15x squared, quantity 3 minus x cubed to the negative 6. Now I'm going to back up so you guys can see. That's what this is referring to. So I'm basically u-subbing this, and it's times the derivative, the du right there. So it means the same thing. Next one. What's my u? What's the u? What is it? Cosine. So my u prime, or du, my derivative, is going to be, okay, negative sine theta. So I'm going to rewrite it now. I'm going to rewrite it. So it's going to be f of theta is equal to u to the third power. know this is going to sound kind of confusing, but I'm going to do the full notation on this now. So the full Leibniz, so when we look at our notes and it says in Leibniz form, I'll show you. So this is going to turn into f prime of theta is equal to 3u squared times d theta du. So what it's saying is this function is there. I'm taking the derivative in terms of what? Of u. So that means that I'm going to plug in here the derivative of u. Again, it will make a little bit more sense when we actually get into the implicit, and why we're doing it. But it's currently just u sub for everything, right? Times the derivative. So this is going to be f prime of theta 3 cosine of theta, and that's going to be squared times negative sine theta. So I could put that negative out front. That would be the only change I would make. Does that make sense? Nonsense? Okay. Other functions. Now, looking at this thing right here, what is this? What is this right here? Product rule, right? Multiplication, there's my product rule. And in the product rule, this piece right here is, I'm going to use a chain, right? I'm going to chain that one right there. So I could use sub that one so I could show my chain. Yeah? Okay, so we're going to do that. So we're going to say that f is e to the x, f prime is e to the x, g is quantity x squared plus 1 to the third, g prime is going to be chain rule, or you could use sub on this one. So now I'm going to cheat, and I want you guys to see. I want you to try and do some mental math here, okay? So remember, my u would be all this inside here, right? So let's pretend like that's u. Okay? So if all that right there is u, I would take a derivative of that, and that would give me, where'd the 3 go? 3 goes out front, right? So it's 3 and my u, which is x squared plus 1 to the what power? Second power, right? Okay, remember we turned it into, we said that's going to be my u, right? So I'm not changing anything to the inside right now. So now we just considered that the u, and now it's going to be times the du, or times the derivative of the inside. The derivative of the inside is going to be, very good. Now, was that so bad? Okay, we've been doing the chain rule a while. Okay, if you still need to rewrite it as u, great. Some of the problems, it's going to be a lot more complicated than this, so yes, I do recommend writing it out. But I want you guys to see the pattern on this. Now, we said this is a product rule, so let's go ahead and just put these together with my product rule. So f prime g e to the x times g, which is x squared plus 1 to the third plus g prime f. I'm going to put my f in front though. So that's going to be e to the x times g prime. Can I rewrite g prime a little bit? I could rewrite it as 6x. Very good. So it's going to be times 6x quantity of x squared plus 1 squared. There we go. And if this is a free response question, I would leave it alone, right? But if it's a multiple choice, I have to try and get my answer to match what they're going to have. So now I'm going to look for common factors. Why do I keep stepping on this box? Ah! And I can't even throw a freaking box. Anyway, is there a common factor in here? There's an e to the x, so let's take out the e to the x. Is there anything else? The quantity of x squared plus 1, right? Okay, is there only just one of those? Okay, they have in common how many? They have 2 in common, right? So if I take away 2 of them, I'm going to have 1 over here left over. So I like changing my parentheses and, changing it to a bracket so I know what's here and where, okay? So it's still a parentheses, but I like using brackets. So when I factor something out, it's out here. Inside the bracket is going to be what is left over. So I'm going to have a x squared plus 1 because there's only one of them left. I took out an e to the x and I took out both those, and it's going to be plus 6x. Does that make sense? No, doesn't need to because there's only one of them left. And there's nothing else being multiplied in there, right? So if there's one of them left, I can take away those parentheses. And because now it's just adding. So let's the commutative property right here. I'm just adding those, right? Commutative property, if I add those together, there we go. So I'm not changing anything. There's no distribution to happen, so I can remove that. There you go. Okay. All right. Anything else? You're still looking at me all crazy, Christian. You good? No? Okay, so you ready? Yeah. Now let's look at this property. Okay? That's the same as what we have, but up here we actually have variables, don't we? Same mathematical rules apply. This says I add those together first, and then I add that. So all together I get 10, right? Okay. Add these two together. X squared plus 1, right? Okay. And then add that one. Just plus 6, right? So it's basically right here commutative. So we get 10 here, but let's change it again. And instead, is that going to change it? 8 plus 2 is 10. Okay. because we had a parentheses here, I still had one left over. Could I remove those? Let's pretend like we actually had 2 left over now, and I'll show you. If I had 2 left over, like that, could I remove the parentheses by expanding it? I could, right? So it would turn into x4 plus 2x squared plus 1, right? And that would have been, right? Okay. Now, let's go ahead, we can combine and just put them back in order. All right, so now, expand this. Right? So it's the same rule. So x squared plus 1 is just x squared plus 1, right? And then that plus 6. Yes, I could rewrite it and now put it in order. Does that make it a little bit better? Yeah. Okay. Vincent, you good there? Okay. All right, so now let's see right here. So I'm gonna remove this, and I'm gonna have to take some more room for this next one. This next one's gonna be a little bit more. 3x plus 2. 4x squared minus 5. All right, identify what type of problem we have. This is a what? It's a quotient rule, okay? But it's inside a chain rule, isn't it? Okay, so now, just for visual sake, I'm going to say U is going to be all this. Yeah? U is all this, and then to get my U prime, I would have to do my quotient rule on that, right? Yeah? So let's go ahead and do quotient rule on that. And I'm going to rewrite this here. So this is my F, and this is my G. Remember, quotient rule is F prime G. So F prime is going to be 3 times G, 4x squared minus 5, okay, minus G prime F, right? G prime F, so G prime is going to give me 8x times F, which is 3x plus 2. And all this is going to be over G squared, right? G squared. So that's going to be 4x squared minus 5 squared. So can I do a little distribution to combine this up? Yeah. And it's probably going to help to actually make it a little bit cleaner. But when we do this, make sure you actually are very carefully distributing addition, subtraction, your signs. So this is going to turn into 12x squared minus 15. When I'm over here, this is probably where everyone's going to make the mistake if you do. What am I distributing over here? A negative 8x. You have to distribute the negative also because I'm subtracting all of that. So that's going to be a negative 24x squared, and that's going to be minus 16x. And all that's still going to be over g squared. So let's combine it up first, and then put it over my g squared. So is there anything combined? Okay, so that's going to give me negative 12x squared minus 16x minus 15 all over 4x squared minus 5 squared. That's my g squared right there. Here's my u prime. Okay, so there we go. So we got our u prime, got our u. Now let's go back and write the original problem. But since I u subbed it, going to blue over here. So my original problem is now going to look like this. It's going to be u, right? U to the 5th power. All that work for something ridiculously. So let's go ahead, and this is going to turn into 5u to the 4th times u prime and now let's go ahead and put that u prime up in there and substitute it back. 5, my u is that hot mess, 3x plus 2 over 4x squared minus 5, close to the 4th power. 4th power times my u prime, which is quantity of negative 12x squared minus 16x minus 15 all over quantity 4x squared minus 5 squared. I remember someone like a couple weeks ago asking, when are we going to get to the problems that take a whole page? Huh? Okay, so where would the 5 be able to distribute into? I almost heard you. Okay, numerator, but where? Why can't I not put it into this one right here? Why can't it not go into this? Yeah, it's to the 4th power, so I'm really not distributing it like that. So I could distribute it, but I would have to distribute to this one over here to put them together. I would have to distribute it this way to the numerator. Okay? Because that is to the 1st power, and I can. I cannot do this unless I expand this to the 4th power. And trust me, I don't want to do it. I teach math, and I'm like, man, that's just tedious. That's like your teacher hates you, and they said expand this. They just want you to be busy for the next 15 minutes. Are we okay still? Not bad, right? Kinda? Okay. Let's see. So guess what? They give you chain rule for multiple composites. So right here, it's going to say your y prime. So we're taking the derivative of y in terms of x, because that's what it's telling me. I'm taking the function y, I'm taking the derivative in terms of x. But now, I'm taking the function y in terms of u. Okay, so when we do that, I also have to have a u prime, right? When I do a u sub, I also have a u prime. So when I do that, that's going to be the function of u in terms of v. So whatever that variable is that I took the derivative for the u's. And if I have to do it again, it's going to be the function of v in terms of x for going all the way back to what I had here. And then from there, what do? Substitute it back in, right? I know it's kind of crazy, and it probably sounds a whole lot crazier than what it actually is. That last problem, we know how to do it. We know how to do the quotient, right? We know how to do chain rule by using substitution, don't we? So now we're just putting all those things together, and that's what this is. Okay, so now we have a couple things here. So I'm going to say that u is going to be 5 cosine theta. Why did I do theta? Why did I do theta? Why didn't I do all this? Because that's another one, right? There's a function in a function, so this is another part of the chain right here. And this one right here, because I could say u prime is going to be -5 sine theta. But we don't have theta in here, right? So I'm going to say theta is 3x plus 2. And then theta prime is 3. So let's rewrite it. Starts off with u squared. Okay, keep going. So from there, I should get 2 u times but then when I did du, didn't I have to have another one? Because I also had a chain on that one, right? Are we following, or did everyone just zone out there? Christian, we good? Okay. Vincent? Okay. So now let's put those together. So that's going to give me, my u is all of this. So that's going to give me 10 cosine of, right here, the inside portion is still my 3x plus 2 times my du, which is going to be 5, -5. Crap, I lost it. I already did that, times the 5, sine theta negative, which was 3x plus 2 times my d theta, 3. And just so you know, I did put, here, I'll rewrite it where I put it. So there was 2 times my cosine, my u, cosine of theta times my negative 5 sine theta times my d theta, 3. I think I might be missing a 5 in this one. Am I missing a 5 right there? Yeah, I am missing a 5. So, put all my coefficients together. That's going to be 10, negative 50, negative 150, cosine 3x plus 2 times sine of 3x plus 2. Yes, no, maybe? Everyone just seems to have died on me recently here. I'm hoping. Let's see. This is our last one. So, sine cubed pi over 2x. Okay. Derivative of the inside is pi over 2, right? Derivative of the outside, sine, is going to give me cosine. Derivative of that is going to give me, remember, think of it as part of my u, right? So if sine's a u, that would be 3. Remember, do I change the u though? It would be 3. So I think that as a u. Remember, 3. So it would become 3. Yes. Sine squared of pi over 2x. Maybe that might actually help, just looking at it a different way and identifying each one as colors. No, maybe? Or we could just do a whole bunch of homework on it and call it good. Let's practice on some homework then. Alright, don't forget, like, share, and subscribe. Hit that notification button. Support my channel. Like I said, I'm gonna have to close down my merch store.